Now, for all principles in circle theorem, this is the one that students, and I dare say teachers, tend to forget. The angle that the tangent makes with the chord is equal to the angle in the alternate segment. This problem requires that we find this angle OAF. That is the angle that we need to find, OAF. And we will progress by making use of the fact that the angle that the tangent makes with the chord is equal to the angle in the alternate segment. So we have those two angles. And what do we mean by the angle in the alternate segment? The angle that the tangent, this is the tangent, the angle that this tangent makes with this chord. Now this chord divides the circle into two segments. We have the minor segment here and the major segment here. The angle that the tangent makes with the chord is equal to the angle in the other segment. And the angle in the other segment is this one. Therefore, this angle is 55 degrees. The two angles are equal to 55 degrees. A portion of one of the angles is 40 degrees, and the other portion is OAF, which is the angle that we need to find, OAF. The other portion is OAF. OAF is therefore the difference between 40 degrees and 55 degrees. This angle is very simple to find. It's very easy. However, we have to make use of a principle that seems to be not so easy to remember. As a matter of fact, throughout my experience, teachers, students, they all have difficulties either remembering it or seeing its application within a circle. However, as soon as we can identify that that is the principle that we need to apply, then the rest of it is straightforward. The angle that the tangent makes with the chord, 55 degrees, is equal to the angle in the alternate segment, which is 55 degrees. However, this portion of it is 40 degrees, and the other portion is the angle OAF that we need to find. OAF is equal to 15 degrees, and that's all there is to it. However, if we should consider that the sum of the internal angles of a triangle is equal to 180 degrees, take note of this blue triangle that we have right there. In the triangle, the only angle that is missing is angle OAF. OAF is the only missing angle. How do we know? It might be not so easy on the eye to see that the angle OAF is the only internal angle of that triangle that is missing. So let us take a look at it. As a matter of fact, it is not even an entire internal angle of the triangle, but only a portion of one of the internal angles of the triangle. We have one internal angle here, 50. We have one all the way here, which is the sum of these two. And we have another one here, which is the sum of these two. The sum of all of the angles in the triangle will therefore be 180 degrees as usual, but this angle is the only missing one in the set. Therefore, OAF is equal to 180 degrees minus 50 minus 35 and minus 2 times, because this angle 40 degrees occur twice and the only portion is missing is this. It turns out that angle OAF is equal to 15 degrees. Because of the apparent symmetry in the diagram, some candidates might want to identify OAF as 35 degrees. Do not forget that the diagram is not drawn to scale and the angles in the triangle would not have a sum of 180 degrees. Although there's an apparent symmetry, 40 degrees, 40 degrees. Isosceles triangle, radius, radius. There's an apparent symmetry. But do not forget that the diagram is not drawn to scale. Additionally, if we say that this angle is 35 degrees, 35 plus 40 will be 75. 75 plus 75 would be 150 plus 50, and that will be 200. So the sum of the angles in the triangle would not be 180 degrees if we should consider that this figure is symmetrical and just look at it and say that this is 35 degrees. It will be wrong on 2 counts. 1, it is not symmetrical because it is not drawn to scale. And 2, the sum of the angles would definitely not be 180 degrees. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.